So today we're going to take a little look at our textbook and hopefully you were able to navigate to the link that takes you to our online text and with the username and password. The username is Stillwater 2020 with the password being Stillwater123. So here's a quick look at it. I'll just walk you through a little bit about what you're going to see, what you're going to read. You'll notice the pages, there's not a ton of text here, so it's not going to be too overwhelming for you. There's some little video clips along the way. But again, this week we're looking at measurement, and we're going to work our way through it. One of the other key concepts is going to be scientific notation. And you'll see a lot of examples using scientific notation in this. Scientific notation, of course, is especially helpful in science because a lot of times we're using really big or really small numbers, and you start putting all those zeros in a number, it gets pretty tough to handle and to work with. And so a lot of times we can't even put that many zeros into your calculator. So scientific notation is going to be really important. So when we do that, we are expressing it as a number of a power of 10, but we start with a number between just 1 and 10, and it becomes a lot easier to work with. Instead of using 300 million meters per second, we can do 3.0 times 10 to the 8th meters per second. And I know the exponents can look a little scary, but once we learn how to handle them, it's going to make your lives a whole lot easier. The 10 to the 8th there, the times 10 to the 8th, just means that I got to move my decimal point 8 places to the right of the 3. For small numbers, for really small numbers, when you got a times 10 to the negative exponent, you're just going to move that decimal point to the other direction. How many places to the left of the to the number between 1 and 10 that you're given? When I multiply numbers in scientific notation, you add exponents together, and when I divide numbers in scientific notation, I'm going to subtract them. That's what they're covering here. There's a number of practice problems then you can work your way through that I want you to do. And notice, it's like 21 pages I'm asking you to go through, but obviously there's not a ton of text on any of those. So good little problem here, an area problem. And we're going to be doing some volume measurements at school as well, and we're going to do some measurements using rulers and so forth. Real similar, trying to plug into these formulas some of these quantities. As I look through there, again, see some examples to go through. And we should be in business with hopefully scientific notation. Now, when we do measuring in science, there's a system called the International System, or Système International d'Unités, if you can speak French, hopefully better than I do. But at any rate, it's a kind of a consolidated system so that scientists will all speak the same language, is what that's about. So we use the same units of measurement, try to help that along, because obviously if we're talking about different units of measurement, sometimes we can get ourselves in trouble, or if we're talking about different things, we're comparing apples and oranges sometimes. So all kinds of different units that we're going to be dealing with. Here you see about for length, okay, where we'll learn about the meter. That's one you're probably familiar with. Mass, the SI unit is the kilogram. We'll probably be measuring a lot of things in our lab. Mostly we'll be using grams, but we'll talk about that in class as well. And then here you see the metric base units for some of the key measurements in the System International Measuring System. A number of units are also called derived units, which are going to be combinations of these base units when they get put together or manipulated in a certain way. And you can see some of these key units that come into play. A number of those we'll be using. Certainly volume and density, pressure, energy, frequency, electric charge, all those are going to be important ones for us that we'll be covering. Okay, and some of those are, like I said, derived units that you have to work some of the base units in order to get to. Um, we're going to stop there in terms of that. So that's about 21 pages of the text. You can see if you want to go further, you can. We're just going to get into some metric prefixes and uh, working our measurements and conversions from there. But that's going to be tomorrow's lesson. Good luck, and we'll see you in class soon.